All right, so just for fun, I decided I would go ahead and do a little extended example and extend it into the debugging for validation. So what I've done is I've taken my form load and I've set my object reference equal to the form itself, and then I've called object, weight bound object dot sum method, and I'm going to set the return value into a variant, and then that way we can include our sum method right on our same form. We're going to return a long value, and we're going to use a hex value that's easy to see. And also, just for a little bit of extra debugging, I've set a long to the object pointer of me, so that way we can determine, like as we're passing arguments to this, and in the disassembly we can take a little bit closer look and you know have a firm identification of what the object pointer is and stuff like that. So we've gone ahead and we've already disassembled this, and here we have our form, we have our two methods. Here we can see that we're setting a literal 4-byte, what BB considers a long, with our hex value, and we're storing it into the argument. And then here we call our var pointer. We're going to be storing it here in var9c. And then we're emoting a reference to our form object again. But actually, this is probably not, well, actually, no, that's correct, because it's this pointer. It's passed into all the methods because it's actually all class-based. When we call our sum method, here is where we believe that it's going to be stored. So what we're going to do is we're going to test our theory out. So we're going to start debugging, then hit F5. You can see that I've gone through and made some modifications to my stack pane. Any changes that happen over here. And the reason this is shown red is because it's actually comparing against my last. I didn't clear it since that was a slight bug in there. So it's doing a diff against the last stack that it saw, which was actually in a different debug session as the bug. So I'm going to we can see that a value was pushed down by the stack. That's going to be our object point. That's going to be our, me pointer. And so what I can do is I can do a control click on this, and I can look at it down here in my stack dump, and I could look at it as a lone address, and then I could come in here and click on that, and we can see what looks like a bunch of addresses in the VB runtime itself. I can click on that and look at the disassembly, and here's the valid disassembly. That is an object pointer. That would be the unknown query interface going on there. So, escape back out of that, go back to our previous view. So I will do an F7, what the var pointer call. So now we can see that this var9c is currently 0. And we can see that now our var pointer, we have a variable up here. That's the same thing that we looked at now. So we'll do an F7, and we can see that the 9c gets set with that same variable. All right, so we'll do, let's see, F7, 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 F7 now. This load PR, anytime you see the load PR, it's actually setting a hard-coded EBC-4C. And we can see that there was there were 0 pushes and 1 modification to our stack, and that turned red. And that's kind of, again, this is one of the features that I've just done for sanity, just so it's easier for me to track what's going on, is, tracking how many pushes, how many pops, how many modifications there were to the stack frame per instruction. So that way I can make sense quickly of what's going on and have kind of definitive answers. So this load PR changed our -4C. And for some of these, VB does some housekeeping down here in the lower parts of the stack. So now I've been naming these as I figure them out, and I'm going to be renaming that one PR. I don't know what it stands for yet, but I'm going to figure it out. Program register? No, it doesn't make sense because it's being loaded. It's always loaded with like an object pointer. I don't know. It'll make sense somewhere along the way. So we can see that our var b0 is currently 0, and I'm going to step over our sum method. We know what it does. It's just very simple. And so this is mem load var is going to be pulling off with this eb_p-4c. And we could actually go into the native disassembly of this as well. And to help us with the native disassembly, I think I already showed it. What if I went to my breakpoints and opcodes, then, I could search for it. And so these are the variations. This is one that we're working on. Lead 0, byte 57, bytecode 57. And what I could do here is I could actually copy the offset, or if I had my IDE plugin going, I could jump to it in IDA. And then we could do some native debugging on this as well to see exactly what this is doing. Right now we're inferring what's happening based on our pcode disassembly. And how we see the pcode stack responding. So we're kind of at a farther out view of what's going on, but it's beneficial if we can figure it out at this layer without having to go to the native disassembly. Like, more power to us, it'll just make things quicker. Some of these can be quite a bear to figure out. I purposefully chose a pretty simple one for these examples. So anyway, our value 0, I'm going to do an F8 and just step over it. And then we can see that our var b0 is 3. So why is it 3? That doesn't quite make sense. We know we're setting it to, and if we come down here into our stack, we can see that 2 values actually changed in our stack. There was one push, and the push is actually this 19FA2C, which is actually our var b0, right? It's the address of it on the stack. So it's using part of the stack to store, and we can see that 2 sections, 2 bits have changed, and one of them is our hex value, right? So what is this 3, and then another word that's 0, and then this 1, 2, 3, 3, 4, right? It doesn't, at first glance, like something's a little strange, right? But remember, we were saving it as a variant, right? So, it saved variant onto the stack, and it put the address ahead of it for the next function to use. So when we're looking at these, we got to take them with a little bit of a grain of salt that there may be embedded data structures here in the stack view that we're trying to figure out. So how do you view those? How are we going to make sense of those? And that's where the data viewer form comes in. So if I click on, now I know you can't see it, but when I do a dwell, my cursor changed to a hand. You're just going to have to trust me on that. So I'll click on it, and it's bringing up my data viewer form. Now, my data viewer form allows me to see data and decode it as different things. So first, we're presented with a hex dump just to get an idea of what's going on. Now I'm going to decode it as a variant, and we can see that as a variant, the VT type is set to 3, which is in human readable terms an I4 or 4-byte number. All the reserves are set to 0, and the data itself is embedded right there with our hex value that we expect. If we thought it might be an array, like we could, click on it and see what it decodes in memory as an array. 3 dimensions, 0 features, 0 element size, an ungodly amount of locks, and multiple balance. Like, this is not a valid safe array structure. But, part of figuring out how all this works is being able to interpret the data in different ways and seeing what it is, trying to figure it out. So that's the kind of data that we got to look through. So we were right in our late mem load var, but that these 2 bytes here were the variable that it was going to be saving it to. And then this was the constant into the constant pool of our string. And with the debugger and with the stack view and seeing what changed and all the other tools that we have available to us, we've pretty much documented this opcode now. So now I could write some documentation on it. And eventually what I'm going to do is, as you're single stepping or as you click out a line in the disassembly, I've reserved this middle pane down here, and that's going to be the help string. And it won't be, some of these have verbose documentation, but it'll be a simple help string, and then you could go to more detailed help in help files and stuff should you need it. So anyway, I just wanted to update that example a little bit and show you guys kind of the next stage of analysis there. So that's what I wanted to share. Enjoy.